Okay, so first thing I want to remind you guys is that your lab, or no, I'm sorry, your Earth Science Regents exam is Friday, June 17th at 11:30 a.m. That will be in the gym for most people. Some of you will be taking it in other rooms. If you're one of those people, Mr. D will probably talk to you. If not, there is a list when you walk in of who's in exactly what room. So that's Friday. I believe I've heard this correctly. You have the global exam earlier that day. So you do have 2 back-to-back regencies, which stinks, but I'm sure you can handle it. What? You don't have the math one the day before? Okay. Some of you have math the day before. Do you have math the day before? You don't know. Okay. Some of you do, I believe. Some of you don't. Make sure you check with your math teacher if you have an exam and when. The other thing I want to talk about is the lab final exam, which is called the lab practical. I know I've talked about it before, but I'll do it again. It is 3 mini lab stations set up. So when I say mini, I literally mean mini. You only get, again, still can't remember if it's 8 or 9. I know I should know this, but I don't. You get 8 or 9 minutes at the station. Some of you do get extended time. You know who you are. So you don't have to worry as much. Again, 9 minutes or 8 minutes is plenty of time if you read the directions carefully. If you don't read the directions, basically like if there's just stuff there and you're like, oh, I know what to do with this ruler, and you start measuring things, turns out you're measuring the completely wrong thing because you have no idea what you were supposed to measure because you didn't read the directions, then you probably won't have enough time. But if you read the directions and do what they say, 8 minutes is sometimes 3 minutes too long. So you will have plenty of time as long as you do what the directions tell you. But anyway, as I have up here, it's going to be given during your lab period, either Monday, June 6th, if your lab's on an E-day. So this is for all the lab teachers. So if you're an E-day with me, Mr. Miga, or Mrs. Saley, you're doing Monday, June 6th during your lab period. If you're an F-day lab, so again, it doesn't matter who your teacher is. If you have lab on an F-day, you're doing your lab during your lab period on Tuesday, June 7th. Or if Mr. D or I have already mentioned to you, talked to you about the lab practical, you're going to be on a different day or time. We don't know exactly when yet, but you will know as soon as we know, okay? One thing I want to say is if you are already know you're going to be absent this day, you have, it's a Monday, so maybe your parents were planning a long weekend. You just need to let me know. I can put you in a different section, but I need to know ahead of time if possible. And if not, I need to hear from you as soon as possible, either the day you come back, or if you could message me the day that you are missing. Even if you're Mr. Miga's lab person, message both of us. So we'll just make sure you fit it in. Because guys, this is your lab regents. If you miss it, instead of getting your starting grade being a 100 on the lab or on the regents, your starting grade's basically an 84. Only meaning you have 20 you can miss instead of 36 or something like that ish. Yes, it's not exactly that simple of math, but you're starting in a big hole if you miss this. So you have to basically take this just like you have to take the regents on June 17th. So again, your lab period, one of those 2 days, unless Mr. D or I have talked to you, then we're going to schedule on a different day. Anybody have any questions about these 2 things I just talked about so far? All right, so in the meantime, today is going to be a work day because I want to make sure you guys have mastered eccentricity. So like I said, if you could turn to page 17, I believe correctly that we finished and went over this page. Okay, there was a few things that came up later in the day that I just wanted to make sure I went over about page 17. So I believe, like I said, this class has the answers already. Oh, that's not the one I even wanted to show. I have more work, more explaining on, that's not the right, this one? Yes. still no. Is it this one? Wouldn't think I would have so many of them. Yeah, this is the one. So with this whole, so this goes with question 5. It said as a planet revolves in its orbit from position A to position D, the orbital velocity will. And this went through a whole bunch of people. The first thing I want to point out is, why does A go the fastest? Why do I have it labeled fastest? So this is an actual. Yes, Jake's got it. Hopefully the rest of you do. If you don't have it labeled, maybe label it fastest. And I'm going to add because it's close to star. So then somebody else, why is C the slowest? Yeah, because it's slowest. And again, because it's far away. So then when you go from A to B to C, you're getting farther away. But then when you switch and you go from B to C to D, you're getting closer. And what you should remember is when you're close, you're moving fast. So when you go from the fastest to the slowest, you must be slowing down. And when you go from the slowest to the fastest, you're speeding up. So that's where we got the decrease, then increase for that one. You did have to use your ESRT. Some people were trying to do this stuff from memory or by looking at it. That one was a struggle where they're like, okay, they looked at this shape and they tried to match it by just like, oh, we know Mercury, or I'm sorry, we knew the eccentricity of these. Which one was that closest to? You actually have to physically do the math. So you have to always find the eccentricity before you can just say which one it's closest to. So I know it's been a couple of days since we did this. Let's see how you do with the questions on 18 and 19, but I actually am going to let you skip. You turn to page 19. You can skip question 13 and you can just flat out cross it off. We're not going to even talk about it. So on page 19, we're going to cross off question 13. And this question at the very bottom, this is kind of review. So that's not about what we're doing right now. That's review from last chapter, but I think you should still be able to do it since you already learned it. So you're going to spend, there's not that many questions. So there's like 7-ish questions. Spend like 10, 15 minutes working on this. The last thing I do want to point out is you do have homework tonight. Your homework is in your Regents little booklet, whether you have the little book or the regular sized booklet that we've been working in. Tonight's homework is questions 41 through 50. So due tomorrow, which is 5, 10, 22, numbers 41 through 50. If you finish in the packet before I start going over pages 18 and 19, you're welcome to get started on the homework.
All right, so what's the goal?
Okay, so to reiterate, so the goal for right now. Thank you. Right now, you're doing pages 18 and 19. You're skipping the one, did everybody cross off the one we're skipping? Skipping 13, question 13. We're gonna do that. Let's see, we do that until, we'll go until, what is that, 11:10? Unless everybody's finished before that. So at 11:10, I'll go over that. If you finish early, your homework is the January 2013, numbers 41 through 50. All right, is that clear now, Jake? Perfect. And We'll go over them at 11:10 unless everybody's finished early. All right, so you should have had enough time to get close to finishing these. If you haven't finished them, still pay attention to how we went over them and you can go back and look at them. It's obviously not for a grade, but you do need to be able to answer these types of questions. This first one threw more than half of you. And I think the reason it threw you off is, again, the same reason they always throw you off. There's so many words that either you skipped or when you read them, you forgot what they said. So it starts with base your answers to 8 and 9 on the diagram below, which shows the orbit of planet D around the star Epsilon Andromedon. The dashed line shows where the paths of the first 4 planets of our solar system would be located if they were going around Epsilon Andromedon instead of the sun. All distances are drawn to scale. So we can see here that this is the star, and they drew our planets going around that star. Again, we don't go around that star, we go around the sun, but then they added planet D. So the first thing you'll notice is D has a much bigger orbit than everybody else. That has nothing to do with the question. So you noticed that, I'm sure, but that has nothing to do with the question. They do have the star labeled. They also label second focus the planet D's orbit. So that's, remember how I always say, read all the words, including looking at the picture. So here's the star and here's the other foci. That's good to know. Here's planet D and here's the path it takes. There's its orbit. Describe the eccentricity of D's orbit relative to the eccentricity of the orbits of the planets shown in our solar system. And the word relative messed you up again. But we've talked about relative. Remember, how old am I relative to you? So I'm older. I'm shorter than many of you. Like I'm shorter than Jesse. It's just, what does relative mean? What word could you use instead of relative? Somebody said it. Compared. So how tall am I compared to Jesse? I'm shorter. How old am I compared to you guys? I'm older. So this is just saying compare D's eccentricity to the eccentricity of everybody else. So what do you think you have to do for D? You got to find it. Eccentricity equals distance between the 2 foci divided by the length of the major axis. Now, distance between the 2 foci means you need to know where the 2 foci are to begin with. So what is a foci? No, what's a foci? Yeah, it's the centers of the oval. So we already know that one of them is always going to be the star it goes around. And the other one's an imaginary dot in space. In this case, they labeled it. So anyone who you have to measure this way across your paper. And when I'm doing it, it looks like I get 2.5 centimeters. And what is the length of the major axis? Got to measure it. It's again how fat the oval is. And it looks like I got 7.8. If you didn't get those exact numbers, it's okay. But then you do the math, 2.5 divided by 7.8. And you got an eccentricity of this number. Now I saw so many of you round this to 0.32. Now the directions didn't tell you what to round it to, but I'm telling you, it's almost always the thousandths place. Thousandths is the third one out. What does the 0 round to then? 1. So it should be 3, 2, 1. But is that the answer? No, because what did the problem ask you to do? Compare it to those other planets. Now, do you guys know off the top of your head the eccentricity of Mars, Earth, Venus, and Mercury? No, so should you calculate them then? Could you? Wait, what do you need to calculate them? What numbers do you need? You need the distance between the 2 foci. They only gave you the other foci for D, so this is not something to calculate. You just look here. Now, planet D has an eccentricity of 0.321. Compare that to the eccentricity of all of the other guys. D's eccentricity is bigger. Now, Justin, did you just write it's bigger? Perfect. If you guys wrote it's bigger, bigger means how large it is. It doesn't talk about its eccentricity. So you needed a full thought. D's orbit has a bigger eccentricity. So if you just wrote bigger, I know you know what you're talking about, but I can't assume that's what you were talking about. So you need a complete thought. D's orbit has a bigger eccentricity. Hey, by the way, does that mean it's more circle or more oval than everybody else? More oval, which you could have also wrote. You could have said D has a more oval orbit. Now it wants to know, it says, describe the changes in gravitational force between planet D and the star Epsilon Andromedon during the complete orbit around the star. Be sure to describe where the force is greatest and where the force is least. If you don't remember gravity, flip back to the page that said gravity, and you remember that the force is greatest when? What? And it's closer. And force is least when? Guys, when is the force least? When it's farthest away. Now the direction said you had to describe where the force is greatest and where it's least. If you didn't include the greatest and the least descriptions there, I would have had to mark it wrong. All right, for questions 10 and 11, you actually had to do the math. You would have had to measure, and I got answer 2, which was 0.7 for number 10 and 0.68 for number 11. So both of those answers were 2. Now the next one, again, do all the reading. And it says, state the actual geometric shape. It is officially an oval or an ellipse. You could have actually said a slightly squished circle, meaning an oval, or a slightly oval circle, something like that. Does anybody have an answer they're not sure is good enough? Okay, technically it's an ellipse. Now 13, you could have skipped. Now here was the problem here. So for number 14, describe the changes that take place in the apparent size of the sun as viewed from Earth, as Earth moves from perihelion to aphelion. So you needed to know 2 vocab words there. What does perihelion mean? So this is when it's close to when it's, what's aphelion mean? Away. So when we move from close to far away, what happens to the size of anything as you move farther away from it? Looks smaller. State the relationship between Earth's distance from the sun and Earth's orbital velocity straight out of your notes. How fast does it go when it's close? Faster when close. And how's close? Slower when? And the last one here, which latitude on Earth receives the greatest intensity of insolation? Guys, when do we get the most insolation from the sun? Where is the sun? Straight above us. So which place? We have 0 degrees. Here's 0 degrees. There's the ground. Here's 66 degrees north. There's the ground. Here's 23 degrees north, and here's 90 degrees north. Who looks straight up to see the sun hitting them at a straight angle? The equator. There's that 90-degree angle we were talking about. Again, you have homework tonight. It is the test booklet, questions 41 through 50.